Good morning, everybody. We're going to be talking about speed and velocity. I'm just going to take a moment to apologize that in the bottom corner of the screen, you do not see my face. My webcam died on me this morning, so unfortunately, until I replace it, we will not be having my face in the lower corner of the screen. So, let's get started. So, speed is a measure of how fast an object travels. If you've ever been riding a car and you'll hear someone talking about, oh, you're moving at 30 miles per hour, 40 miles per hour. In baseball, they measure the speed of pitches. In track meets, they actually measure how fast different runners are going at times. These are all measures of speed. One thing about speed is always a number. Well, because speed is a number, we are actually able to determine that number. Here in the center of the screen, if I can get my pen, boom. Wait, no, there we go. This is the formula for speed. Speed will equal your distance traveled divided by the time it took to travel. It's always a simple formula of distance divided by time. Now, the line under that is actually super important, where I say speed can never be negative. What do I mean by this? Speed is simply saying how fast you're going. Speed does not care if you're going forward or backwards. All it cares about is how fast you're going. That's simple. So on the next slide, I have an example problem. So let us flip there. So here's what I want you to do. I'm going to read the problem real quick, and then after I read it, I want you to take a moment using what I said in the previous slide to try and answer this problem. So a car goes 60 miles in 5 hours. What is the speed of the car? So do me a favor, pause the video now and then take the time to try to answer the question. Once you've come up with an answer, I want you to press play and see what I say that answer is. So, hopefully now you've paused the video and you've come back. First, let's go back and take a look. Speed equals distance divided by time. That is our formula. So, we are going to write it. Our speed is going to equal distance divided by, I'm going to make the division symbol, there we go, time. So, if I ever ask you what the speed of an object is, this is always what we're looking at. We're looking at like the actual factual speed. Give me a different color. So first things first, when we have a formula like this, we want to find our pieces. So the pieces of our formula here are our distance, which I just wrote dist because I'm lazy, and our time. So first things first, in our formula, let's look for our distance. Well, our distance traveled is going to be 60 miles. Okay, so that's the first piece. So now our second piece, let's switch to purple. Time. What is our time that we traveled? Well, our time is 5 hours. So now, since we know it's distance divided by time, is going to be 60 miles, which is our distance, divided by 5 hours, which is our time. So it will be 60. That is, there we go, 60 miles divided by 5 hours. So now at this point, what you can do is you can honestly just take a calculator and plug all of this in. So if you were to take your 60 miles divided by 5 hours, the answer you're going to get is 12. Now, here's something super important while doing this. You cannot simply put the number 12 and say my answer is correct. This is not a correct answer yet, and here's why. We said we were traveling miles and in hours. Those are important pieces that we need to reflect in our answer. So it's really, really easy to do this next piece. So our distance was in miles. Our time was in hours. So that means our speed, when we write our answer of 12, we need to use both miles and hours in this answer. Speed, it's always going to be your distance per whatever time you had. So since it's miles and hours, it's going to be miles per hour. Now, if this is minutes, this would change to minutes. If this said feet, the first part would change to feet. It's always based on what this and this are. What your units of your distance and your units of your time. So those will always affect how you write your answer. So if I say, oh, we moved 100 feet in 10 seconds, then your answer would be in feet per second. It's always your distance per time. That's just something I kind of want to make sure you guys understand because it's very, very, very important. So let's move to the next slide. All right, velocity. So velocity is actually pretty simple when we look at it in terms of speed. So what happens is speed is just how fast you're moving. That's simple. Velocity is your speed in a specific direction. So what I mean by that is if I'm moving forward, I have one velocity. If I decide to start moving backwards, I have a different velocity. I could be moving at the same speed, but because my direction is different, my velocity is different. So velocity, it's speed in a specific direction. That direction is very important. So what ends up happening here is because velocity cares about its direction, velocity can either be a positive or negative number. This is mostly just you'd write it's positive or negative in order to show what direction the object is traveling. So if an object is moving forward, we would say it's moving in its positive velocity because it's going in the positive direction. If it's moving backwards, it's moving in its negative direction. It's like, for example, if you were driving and you knew you were trying to go somewhere and you started moving towards your location, you're obviously moving in the positive direction because you're getting closer to where you're trying to go. But let's say you start getting further away from where you're trying to go. So you're trying to go to the store, and instead of making the right you're supposed to make, you make a left. Well, now, because you're going away from the store, you'd be moving in a negative direction. That's kind of how I want you to think about it when I say this velocity can be positive or negative. Positive is moving towards your destination, while negative will be moving away from your destination. Now, velocity, because it uses the same formula as speed, I don't have a specific problem for that. But I just kind of want to make sure you guys know that speed and velocity, they are not the same thing. They have a minor difference, which is just velocity has a specific direction. And last two slides, we only got one more slide after this, acceleration. So an acceleration is an object's change in velocity. So you've probably heard the word accelerate before. Whenever you hear the word accelerating, people always think of like, oh, you are speeding up, you're putting the foot on the gas pedal, you're going to go faster. Well, that's one of the three different forms that acceleration comes in. Either acceleration is A, you are speeding up, you are going faster. B, you're slowing down, you're moving slower. Or C, you are changing direction. These are the three different forms that acceleration can take. Now, that being said, we actually have a formula for acceleration. This is one of the more complex formulas I'm going to be giving you, but I don't think it's that bad overall. So let me just circle it here. So our acceleration is equal to our ending velocity. So the velocity we end at minus our starting velocity. This entire thing, whatever this answer is, divided by time. I think that at this point we've done all of our order of operations stuff. So just in case you haven't, this parentheses here, if you don't know this parentheses means you do everything inside of it first. I'm pretty sure you guys have done this at this point, but just in case, I want to make sure that we know that. So that means you do your ending velocity minus your starting velocity first, and then you divide whatever you get for this, you divide it by the time. That will give you your answer. Now, your acceleration can be a positive or a negative number, depending on what happens. If it's a positive number, it means you are moving faster. If it is a negative number, it means you are slowing down. When we actually talk about slowing down, people frequently will use the term decelerating. Deceleration is another form of acceleration. That's simple. So now let us move to our practice problem. All right, acceleration problem. So once again, I'm going to read this to you guys, and I want you guys to just take the time and just kind of start working on it on your own. Obviously, pause the video to work on it, and then press play, and then I'll go over it. So a car is moving at 20 meters per second. We're going to underline that. In 2 seconds, the car accelerates to 60 meters per second. What is the car's acceleration? Well, first things first, we were given a formula, which is, boom, acceleration equals ending velocity minus starting velocity divided by time. So I'm lazy, so instead of writing acceleration, I'm going to put A for acceleration. It's going to be equal to our ending velocity, so I'm going to put end V minus our starting velocity. For that, I'm just going to put start V. All right, and once we do that, that will be divided by our time. Oh my God, I made the world's ugliest eye. Oh my goodness. Well, while I fix my eye, let's take the time to now figure out what all these different things are in the formula, or excuse me, in the problem. So if you notice, as I read through the problem, I actually underlined important pieces of information. This is honestly a good way to approach problems like this. You underline the important pieces of information, because this way, when you actually get the formula, you write it out, and you're like, okay, well, what's this? What's that? So first things first, let's find our ending V, which is our ending velocity. Well, our car is moving at 20 meters per second, but that's what we start moving at. And then in 2 seconds, our car accelerates to 60 meters per second. Because our car accelerated to 60 meters per second, we know that this is going to be our ending velocity. So that's going to be 60 meters per second. Okay, so that's the first one. Next, what we need to find is our, is it different? No, it's not different enough color. That's like almost identical. Let's go with orange. So next we have to find our starting velocity. Well, let's read the problem from the beginning. A car is moving at 20 meters per second. Easy enough. This is right in the beginning of the problem. It tells us this is what our car was moving at. So we know our starting velocity is going to be 20 meters per second. This means the same as this. I'm just writing it differently just to save myself a little bit of time. And then lastly, but certainly not least, we need our time. Well, we do say in 2 seconds. So in 2 seconds, boom. So that means it'll be 2 seconds. So now that we have all of that figured out, what we will need to do is we need to do the math. Now we need to order the operations. We have the parentheses here, so we do this first. So first is 60 minus 20, which will give us 40. And then it will be 40 divided by our 2 seconds. So if you plug that into a calculator, it'll give you an answer of, I'm going to change my color one more time. It'll give us an answer of 20. So our acceleration here is 20, but we need to write the units for it. So we know that our speeds were written in meters per second. So obviously, if you're writing your speed in meters per second, excuse me, your velocities in meters per second, this one isn't going to change all of a sudden. And then it was meters per second divided by seconds. So what ends up happening is the way we end up having to write this is going to be meters because we use meters here per second, just like it was meters per second before. But since we have 2 seconds, what we're going to do is just a little 2 up there. Boom. Meters per second squared. I'm honestly not going to give you guys too much grief over the units for stuff like this. The units for this is a little bit more complex than what you guys are really going to be getting into anytime soon. You guys are probably going to go over this in 8th grade a bit more, but I want you to at least know that these are important, all these unit numbers. Going into this, most of this is just simple math. It's just plug everything into the formula and then solve for your answer. The hard part is figuring out where everything goes, but that's something that as you practice it, it will get easier and easier. Alright, so that being said, oh god, hold on, oh god, I actually didn't mean to come all the way out like this. So that being said, what I want you guys to do is I'm going to have a Google form set up. It's only going to have a couple questions, not too many today, because I do want you guys to get used to finding your formulas, make sure you know what your formulas are, and know what a couple differences between different things are. I think I'll have a grand total of 5 questions is what I'm planning on. So that being said, get to work on that for me and have a good day.